Right now we are in briefing of lab BC1303. Okay, for this briefing we will look into the simulation or simulator of TinkerCAD software. Alright, so this software will be available online. Okay, you no need to download the software. Alright, we just go into the website and then register, then you can start to use the simulator. Right, so this is an example of component placement on the breadboard. Right, so the example is using the resistor. Okay, so here is resistor is connected in series. Okay, here is R1 and this is R2. So these two is these two resistor is connected in series. So number 2 is two resistor connected in parallel. So this is how you connect a component as parallel on the breadboard. Okay, so this is how you connect the resistor. So this is R1 and this is R2. Okay, and number 3 is the combination of parallel and series. So basically this connection or this resistor are in parallel, but then it is series with the resistor, the third resistor. So we consider this R1, R2, and this resistor is R3. So R1 and R2 is in parallel, but R2 and R1 and R2 is series with R3. Okay, so this is how you place the component for series and parallel and series on the breadboard.
Alright, this is how you measure the resistance using the analog or digital multimeter. Okay, we know that component, or for example in here is a resistor, we have two terminals. So the positive terminal we put at one terminal, and the negative terminal we put at terminal 2 for the resistor. So this is how you measure the resistance using the multimeter without turning on any power supply or connecting any power supply to the resistor. Okay, this is how you measure a voltage. Okay, you have one resistor. Okay, you put in on the breadboard. So you connect to measure a voltage. So you need to have a power supply and a resistance. Okay, so to measure it with a multimeter, so the positive terminal for the power supply connect to one terminal at the resistance, and the negative power supply terminal of power supply you connect to another terminal for the resistance. Okay, then positive terminal from the multimeter you connect to the positive terminal that you connect the power supply, and negative terminal for the multimeter you connect to the negative terminal of the power supply. So that is how you measure the voltage, okay, while you put the components on the breadboard. Alright, this is how you measure current using the multimeter. So you connect the positive terminal of the power supply to the resistor, and another terminal from the resistance you connect to the positive terminal of the multimeter. So the negative terminal of the power supply, you connect it with the negative terminal of the power supply. So as in this figure, okay, you can see that this basically the multimeter is part of the circuit. Okay, so this is how the connection that you do on the breadboard.
Is the software that you use for this lab. Okay, so open up your lab sheet and then you go to the TinkerCAD link that I provide you in the lab sheet. Okay, you will go to your dashboard. Okay, so for those who have registered for the TinkerCAD, okay, your dashboard will be like the one that I'm showing you, right? Okay, and then for those who haven't registered, so you need to register first before you can start to use this software. So then once the Windows is showing your dashboard, okay, you need to select the circuit. So you will be point out this one. This is what I've done. Here is the circuit that I've done. So for the new one, okay, you need to create a new circuit. Alright, so it will appear like this. Then for the person, okay, on top of the left of the window, okay, you will see the rotate button, the delete, okay, undo, redo, and also annotation, and this is also view of height. So on top of the right, you will see the code, and then the simulation start and stop button. Then you can export your circuit and share. Okay, so okay, at the bottom of right, not really the bottom, the right side, okay, you can see your component list, which is resistor, LED, push button, potentiometer, so on and so forth. Okay, for you to begin in constructing the electronic circuit, okay, you will need a base to start your circuit. Okay, now we have a breadboard here. You need to select the breadboard. Okay, click on breadboard and it will appear on your screen window. Right, so you place it and you rename it as your breadboard. Alright, or you can, whatever name you can put, okay, so your name is easier. Okay, so for those who haven't done, who haven't using the breadboard before this, okay, so let me show you the connection. Okay, I will zoom in. Select this and go to um, okay. Right. So the connection for the breadboard, okay, you can see on top and at the bottom, here you have positive and negative sign, okay, for both sides. So usually the negative side is representing the ground or negative terminal. Okay, so for point this one, okay, this is considering all the hole is connected together. So if you put any in any hole, both all the hole are connected. right? Same goes to the positive terminal. Okay, all of these have connection. It is the same level or same point, right? And same goes to the bottom one. These are the connection in the breadboard. So this is also the connection. The difference from the middle hole, okay, the connection of the board is from A to E. It is, if we see like this, it's vertical, right? So from at line 1, the whole A, B, C, D, E is connected together. So same goes to line number 2. So the whole A until E is connected. Okay, same goes to this one, because you can see once you click the hole, okay, you can see other hole also is highlighted, right? So that means that all the hole is connected together. Okay. And same goes to the line number 1 for F, G, H, I, J. So the connection also like this. Alright? Okay. So but for the whole of line number 1 for whole of E and F, it is not connected, right? So it has a drain in the middle of the breadboard. Okay, so the connection is same from line 1 until line 6. So this is the same. Okay, so that is how the connection for the breadboard. Okay, so now I want to show you how you can place the component on the breadboard. Alright, so let me delete this. Um, Let me delete it first. If you want to delete the wire or the component, you need to highlight it. You need to bring your cursor on that and click on the particular component or wire. Then you can delete here, or you can just uh, press delete on your keyboard. Alright, so it will be delete. Then okay, I just want to show you the example on how you want to measure a current and voltage, and also the resistance on the breadboard. Okay, so just just a simple circuit. So for you to do your lab one. Okay. Alright, so let me pick some resistor. Okay, so you can just put the resistor anywhere on the breadboard. Okay, so just pick one point and name it as R1. So these are the value of resistance. So we select. Okay, so here I don't want to change the. You can change the value of the resistor to nano ohm, micro ohm, milli ohm, ohm, kilo ohm, mega ohm, and giga ohm. Right. So for here I didn't want to change, so the default value is 1 kilo ohm. So you already know this resistance is 1 kilo ohm. So okay, then before I proceed, okay, remember that E and F has no connection just now I mentioned, right? So why I put the resistance here, because there will be no connection for terminal 1 and terminal 2 of resistance. Why? Is it correct if I put like this? Okay, so this is not the correct way on when you want to place your component on the breadboard, because as I mentioned previously, the line, okay, the hole for FGHIJ is connected together. If I put like this, that means that you shorted the resistance. So the resistance will be low, or it will not meeting the purpose of you using the um, resistor in your circuit. Alright, so you can change, you can also rotate the component. Again, you highlight the component, and then you click rotate. Okay, it will rotate the component. So if you put the resistor like this, okay, it it is the correct way. Why? Because line number 3 and line number 7 is not connected. We don't want terminal 1 and terminal 2 for resistance shorted, okay, because it will be low, right? Okay, so now, right, so we continue back. Okay, once you already put your resistor, okay, now we start check you place the multimeter, okay, here the multimeter, and also can we put it here as F1, okay, and also the power supply. So power supply, okay, if you can't find it, you can just try to search for it. Okay, power supply. Okay, we use this type of power supply. Okay, power supply, right? So name this one as this one. Okay. Okay, for example here, I just, we are not applying current, we just put 5 volt of your power supply. Right, okay. So remember, when you want to measure the resistance, don't connect or turn on any power to your circuit. Okay, first we connect um, the multimeter to the resistance. So, sorry, I think I want to rotate the resistor. I put it here. Right, so positive, and one, okay. Um, one, and now let me open two. Um, Before you compute, we change the positive terminal to the and the negative terminal to right, and then here the positive right, and change it to leaf, and the negative to change it to black. Okay, so now we have to complete the Multimeter. Information. Sure, it's not. If you measure the resistance, remember that you don't turn on any supply to your circuit. Okay, don't. Now I'll start the simulation, but make sure your power supply is turned off. Then only you will get the value of resistance. Okay, so 1000 ohm is equals to 1k. Okay, you know just now that the resistance here, okay, is 1k. So it is correct that you measure the resistance here is 1k. Okay, and then click stop simulation. Then okay, now if you want to measure the voltage, you can to measure the voltage, you click the power supply again. So let's say you apply 5 volts to the supply to the circuit, and then you start the simulation. Oh sorry, you need to change your multimeter to measure a voltage, right? And start again start simulation. It will automatically measure the voltage that you apply is 5 volt, right? So now you want every time you want to change the parameter, you need to stop the simulation, right? Okay. So now we want to apply, we want to measure a current. So remember that when you want to measure a current, you need to put your resistance. Sorry, you need to put your multimeter in series with the circuit or into the circuit. Okay. If you want to measure a voltage, you just put your multimeter across the resistor here like this. Okay. But if you want to measure the current, you need to put the resistor into the circuit. Okay, for example, I change the circuit to the connection of the circuit. Right. So in order for you to measure the current, okay, so your multimeter must be in the circuit. So I just put 1 voltage. So and let's rewire it. So negative change this. Change Change to ampere, right? And the negative is positive, connecting, and this one, yes, yes, this one, change to black, change it to red, change it to red, okay? So check again your power supply, so you have here, right? And you start a simulation. Okay, when you apply a voltage, so your ampere will be 5 milliampere. This is what you get, okay, for your circuit. So if you want to verify your value of the ampere that you get, you try to apply the Ohm's law, which is the V equal to IR. So you will get for I is equal to V over R. So in here you apply 5 volt, so your V will be 5 volt. So over the resistor is 1 kilo ohm. So you should get 5 milliampere. So the multimeter is showing that you are getting the correct result of ampere, right?